Alright, welcome to lesson 12-5. Still analyzing data in this chapter. We're going to learn now how to make and analyze a scatter plot and how to interpret the trends on the scatter plot. So a scatter plot is a graph that shows a relationship between two sets of data. So you're going to have some sort of set of data over here. It's labeled and something over here. Right, and we have our X and Y axes. Only the positive quadrant for these, for most of these scenarios that we're going to be describing. So say you have the point 1, 0. To graph on a scatter plot, you're just going to put graph the data as ordered pairs. So 1, 0 is the point right here. If you also had 2, 2, you could plot that point as well. And you're just going to be plotting points. And the points are scattered. You're not drawing a line between them. So you graph your data as individual ordered pairs. So we're going to take a look at a scatter plot to begin with. So we have this graph entitled Learn and Earn that shows the years of education completed compared to the annual income in terms of $1,000 each per increment. So we have 10,000. Those are our two axes. So we're comparing years of education to how much money they're earning in the thousands. So 10,000 is what you earn if you've worked 8 years, or possibly 20,000. So 10 or 20,000 are what people are earning for working 8 years. So if I asked how many years of education does a person need in order to earn $100,000? Well, we're going to look over at the graph, and we'll find 100,000. So we'll go up to the 100,000 line, look across to where there's a point. There's a point at 16. So it takes 16 years of education to earn $100,000. Go ahead now, and I want you to, looking at this data, describe the person represented by point A. Describe also the person represented by point B. And then describe or determine how many people have exactly 12 years of education. Pause the video and find and solve each of those problems. Hit play when you found the answers. Alright, you should have said that the person described by point A has 12 years of education. So on the 12 on the x-axis, and earns $20,000 a year. So it's on the 20 on the y-axis, and it's in terms of thousands. The person at point B has 14 years of education and earns $90,000 a year. And there are exactly 4 people, there's 4 data points, who have exactly 12 years of education. So from the scatter plot, we are able to just glean some information, like, are there a lot of people there's not many people who only have 8 years of education, only 2. There's one person who has 9 years of education. There's a lot of people who have about 12 years of education. There's 4 4 numbers there, 4 people there. Same with 16 years, there's 4 sets of data there. So you're able to kind of tell certain things about individuals and about like the trend for the overall data set. So we're going to go ahead now and we're going to make a set of data or make a scatter plot using a set of data. See, some graph paper. It's a little small. Okay, so if I have this data set showing climate data, we're going to make a graph showing a scatter plot for the latitude, so the location, and temperature. So those are the 2 things that I'm going to compare. So I'm going to make my x and y axis. Oops. I'm going to label my 2 different sides. So I have my location. I'll put as my my x-axis. That's the latitude. And then I have my temperature, my daily temperature, as my y-axis. Now, looking at the data here, it ranges for location from about 21 degrees north latitude to 58 degrees north latitude. So my increments, I'm going to go up in terms of 5. Whoops. I'm going to leave a little room to write here. Location. And I'm going to, on this graph, do 15, 20, 30, 40, I'm skipping every other so I can go up by 5s, and 50, and then 60. Now for my temperature, so this location is in terms of degrees north latitude, and my temperature is in terms of degrees Fahrenheit. I keep doing that. Degrees Fahrenheit. And my increments here, I'm going to go up, I'm going to look at my set of temperatures. My smallest temperature is 39 degrees. The greatest temperature is in the 70s, 77. So I'm going to start at 0. I'm going to put on my chart here up to, let's see, we'll go up by 20s. So 20, 40, 60. Maybe I'll go up by 10s. Maybe that'll be better. Okay. 20, 40, here's 60, here's 80. Alright, so now I'm going to take and I'm going to graph these different sets of data points. So I have 34, 61 as the data point. So 34, 61 is the point for Atlanta, for examples, right? That's Atlanta, Georgia. I have 42, 51, 42 degrees north latitude, and 51 degrees for Boston. 42, 49, wait, I think I'm a little off there. For Boston, it should be 4239. Then Illinois, Chicago, Illinois, 4249. Then we have 47 degrees north latitude at 37 or 4739. Boston was 51. Okay. Hawaii is 21 degrees north latitude and 77 degrees. Houston, Texas is 3068. Then we have 58, 41, then 26, 76. 33, 73. 44 is 45. 33, 64. 38, 56. All right, so I've plotted all my points. So you can see, after this scatter plot, we're comparing temperature and location, and you can see an overall negative trend, right? This downward trend happening on this graph. I'm going to have you now practice, make a scatter plot for latitude and precipitation. Okay, and so instead of comparing latitude and temperature, compare latitude and precipitation. So it's using the same data as up here. And this time you're looking at latitude, precipitation. Okay, go ahead and do this. Hit play once you've done it. All right, your graph should look something like this, showing precipitation on one axis in terms of inches, and then the location in terms of degrees north latitude. So the data on this plot, you can see really ranges compared with our last diagram here comparing temperature and location. There's like a steady decline as you go lower in temperatures get lower, decrease as you go upward in terms of latitude. Temperatures go down as you go upward in latitude. Here you don't see that same trend. Here you see the data is really scattered all over. There isn't such a trend. So I'm going to give you now 3 ways to describe describe the trends that we see. Trends of data. There's what we call a positive correlation, that if you have your graph, here's 0 in your graph. So positive correlation is going to look something like this, where you have some points, and generally, as you increase on your y-axis, you're increasing on your x-axis, or x-axis and y-axis are both increasing. Right? So there's an overall like upward, you could kind of draw this imaginary upward line through the middle of your data. Most of the data points seem to be increasing positively in both directions. As one set of values increases, the other set of value increases. The opposite of that is going to be your negative correlation. Where as you go, there's this general kind of downward negative sloping line you can almost draw through your data sets. So this is as, how do I describe it? So as I increase on my x-axis, my y-axis is going down, or if I increase on my y-axis, then my x-axis is going down. So you have this, as one set of value increases, then the other one tends to decrease. Correlation going on. It's called a negative correlation. Your third way to describe a data set is saying that there's no correlation. This is when the data plots are scattered all around. There is really no trend, no way you could kind of draw a line through your middle of your data sets in order to kind of describe the data set. Right here on this positive correlation, you can see that most of the points look like they fit kind of close to that line I drew. Just like on the negative correlation plot, most of the points or data points kind of fit alongside that red line I drew that's going down, a negative line. For the no correlation graph, the data points just kind of floating all over the place. There's not a way you could draw a line through the data in order to kind of describe it. So there's no value or no relationship between the different values. So we're going to do look at some examples here. So we're going to look and see if we can find a trend. So looking at this scatter plot, we're going to see, does it have a positive, negative, or no correlation? So looking at the years here, we're increasing in terms of number of years. Or we're going from 1952 up to 2004. Along the x-axis, we're going from 12.8 to 13.8. But as I go along this graph, I can almost like draw a downward sloping line through this data, right? Most of those points fit along this line for the men's 110 meter hurdles, right? The time in seconds since 1952 has decreased. So since 1952, the time when, or the winning times, have generally decreased. People have gotten faster over the last 60 years. So they're showing a negative correlation. Right, as we've increased, as we have increased in years, like as years have gone on, so our number of years has gone up, but the time, the seconds it takes to win, has gone down. Right, so this opposite correlation that tells us a negative correlation. All right, now I want you to look at the women's long jump. So the winning distances compared to the number of years. What kind of trend do you see there? Is it a positive correlation, negative correlation, or no correlation? And explain to me, come up with a reason why. Why you think it's that correlation. All right, you should have said something along the lines that, well, first of all, that there's a positive correlation. And you could have explained this by saying that as time goes by, or as time increases, then the winning distances have tended to increase. Right? This is the winning distances in terms of meters. So as from 1952, the winning distance was about 6.3 meters, but by 1996, the winning distance was over 7 meters. So as time has increased, the winning number of meters has increased as well. So as time is going on, you have to be able to jump further in order to win. In 1952, you could have been able to jump 6.3-ish meters and won. But now, upwards towards 2000, as time has gone on, you now have to be able to jump closer to 7 meters or beyond in order to win. That's a positive correlation. Alright, so now that's it for this lesson. I'm just making scatter plots, being able to kind of analyze the data, recognizing if there's a positive correlation, negative correlation, or if there's no correlation at all. The data sets just aren't related to each other. So your in-class practice is on page 631 in your textbook. I want you to do numbers 1 through 8 all. And then your homework is the 12-5 practice book page, a workbook page. So you can go ahead and get started on that now. If you have any questions, please ask your teacher.